is important that I want to tell you here is that let's recalculate what we have seen. We have seen step 1 in which we had made the transportation table, right? So in step 2, can anyone tell me what we have dealt in step 2? We have found out the initial basic feasible solution. We have seen the various methods. So we have seen the northwest corner method. We have seen row minima method. We have seen column minima method. We have seen least cost method. And lastly, we have seen VAM method. So when the pattern there is that you don't have to find out the initial basic feasible solution using all this all these methods. So you will be solving or you will be finding out the initial basic feasible solution only with the VAM solution. Why? Because VAM solution gives this initial basic feasible solution of a high quality. So you'll be doing it by only VAM method only, and all these other methods are going to give the initial basic feasible solution, right? But what we have to do is we don't have to stop with the initial basic feasible solution. Our main aim is to get an optimal solution, right? And that particular, if we take into consideration the northwest corner method rule, or RMM or CMM or least cost, for all this what will happen is that the number of iterations that will be required for reaching towards the optimal equation will be more, right? But in case of VAM, what will be there? These particularly you will be getting less iteration. In 1 or 2 iteration particularly you will be reaching towards an optimal solution, or in many cases what may happen is that your VAM solution itself is an optimal solution. So that particular thing can also happen, right? Now what we are going to do is we are going to do step number 3, which is check for optimality. We are going to check whether the obtained initial basic feasible solution is optimal or not. That we are going to check. Right now, the initial basic feasible solution that we have obtained is optimal or not. If that is optimal, then okay, we have reached to the solution. But if it is not optimal, what we are going to do is we are going to iterate towards optimal solution, right? If we are going to iterate towards the optimal solution, we'll be iterating, we'll be finding the new solution, and again we'll be checking if that solution that we have got is optimal or not. If not optimal, we are again going to repeat this, and we are again going to repeat this particular step. So there is an iteration that is involved, and that particular you will be continuing with the iteration up till the optimal solution is obtained to us. Right now, what we are going to do now is we are going to proceed towards our step number 3, that is the check for optimality. All right. So now checking whether the initial basic feasible solution is optimal or not, that is very, very important. The optimality, before starting or checking with the optimality, what we have to do is that we have to check whether that particular solution is degenerate or not, right? So how to identify the degeneracy, that we are going to see. Now that can be obtained by you have to check that the number of allocations that we have done is equal to m plus n minus 1. ठीक है, तो हम लोगों ने कितने allocations किए है, उसका जो वैल्यू है वो m plus n minus 1 से होना चाहिए. So what is 1m here? M is it is the number of the rows, and your n is number of columns. So if these two are matching, then only we can do the optimality check. If this is matching, then it is okay. If it is not matching, there is some different method. So that we are not going to see in today's lecture, that we are going to see or cover in the variation part. But we have to check this, and then only we are going to move forward. So this is our first step, that is the number of allocation should be there, and each allocation should be independent. That is also very important before starting with the optimality check. So now we cannot check the B point, that is each allocation should be independent, that we can check, but no, again we have found out the initial basic feasible solution. Normally this is already taken care of when we do this, but what this actually independent means is that there is no loop formation, right? So there is, I'll be writing here, no loop formation, or precisely no closed loop formation between the allocated cells. So if that is so, then we call it as an independent, all these allocations are independent. So now that loop formation and all that, I'll be telling you how that we check, because that is required in our next step, in which we are going to check for the optimality. Right. So particularly when we are going to check for the optimality, we are going to follow these two methods. And now the very first method, so step 3, we can use two methods for checking the optimality. Right, and these two methods are stepping stone method The other method that we are going to see is the modified distribution method, also called as Modi method, what we can say, Modi method or UV method. Right. So these are we are going to see the stepping stone method, and other one is the modified distribution method. It is also called as Modi method or UV method. Right. So these are the two methods that we are going to see. In today's lecture, I am targeting to finish the stepping stone method. Right. It is again simple, requires patience for understanding and also for solving. Right. So let's move ahead and understand what is the stepping stone method. So you have this as stepping stone method. Firstly, for this you have the input from the VAM method, right? So solution obtained from VAM is, so that is that is to be considered. Here you have right 1 2 3 4 1 2 3, right? So here it is 2 3 11 7 1 0 6 1, it is 5 8 15 9, right? So this is the solution. The solution is like this: 1 5 1 6 3 and 1, right? So the number of allocations. So before starting with the optimality, right? So before starting with the stepstone method, we'll have to check whether there is a degeneracy or not. So here, number of allocations that we have, number of allocations is equal to 6. M, the value of M, that is the value of rows here is 1, 2, and 3, and the value of N here is 4. Therefore, M plus N minus 1 is equal to 6. Hence, we can proceed in for this optimality check, right? So now for the optimality check, what we are going to do is very simple, right? So I'm redrawing this particular here because I need a big space. We have this allocation here, that is 1, 5, 1, 6, 3, and 1. All right. So now what we are going to do is we are going to consider each and every non-allocated cell. All right. So which are the non-allocated cells here? These cells are 1, 3, right? This particular cell. Then we have this cell which is 1, 4, right? We have this cell that is 2, 1. We have another cell that is 2, 2, 2, 3. We have 3, 2, right? So these are all the unallocated cells here, right? So now what we are going to do is that, okay, it's okay that we have done the allocation from VAM method and we have got some allocated cells. But what if we would have done the allocation in the unallocated cells, and whether there is a possibility or not that if we would have put the allocation in the non-allocated cells, the total transportation cost will get reduced. So that we are going to check. I'm repeating the statement. It's okay that in VAM we have done some allocation in some particular cells, and those are the allocated cells. But what if I'm doing some allocation in the non-allocated cells now, and I'm going to check whether that particular allocation in the non-allocated cells is further going to reduce my total transportation cost or not. That particular I'm going to check. Now here it is very important that now I want everyone's attention how we are going to check with this. Right now, what we are going to do is let's consider our first cell, that is C. Our first non-allocated cell, that is 1, 3. Now I'll be doing some allocation here, right? I want to do some allocation in this particular cell without disturbing the initial constraints, which are the constraints of here the supply and demand, which were 6, 1, and 10, and we had here as 7, 5, 3, 2. I do not want to disturb this particular constraints, but I have to do the allocation here. So what I'll be doing is I'll be doing some allocation here. I'll be doing unit allocation. I won't be putting any arbitrary number, right? I'll be doing some unit allocation. So unit allocation in this particular cell, let's say that I have done this unit allocation 1 in this particular cell, right? But now what has happened, I have disturbed the entire constraint constraint of this entire numerical. So now what has happened, 1 plus 5 plus 1 has become 7, and even 3 plus 1 has become 4. So that is not acceptable. So I'll have to reduce from somewhere so that the constraints get satisfied. So from where I'll have to add it somewhere, I'll have to reduce it somewhere so that these constraints get matched. So now what I'm going to do, I'll be doing some unit allocation, and I'll be forming the loop for this particular allocation. So now loop can be formed from the allocated cells only. You can take a turn in the allocated cell only. So you can take a left turn, you can take a right turn, you can go in a reverse fashion, you can go in the clockwise, anti-clockwise cells, but provided you take a turn in the allocated cells to frame out the loop. So now I have to frame out the loop for this cell 1 3. So I'll be framing out the loop for you, and now let's check whether you understand this or not, right? So the loop will be moving in this particular fashion, right? So I have got 3 here. So this is the allocated cell. In allocated cell, I can move either in this direction or I can move either in this direction, right? So what I'll be doing, I'll have to form a loop. So I'll be checking a possibility. So I'm moving in this direction, right? In this particular cell, there are 2 options. I can know there is only one single option. I'll have to move in the upward direction only, right? So I'm moving in the upward direction, right? In this particular cell, again, there is one option that I have got to move in this direction, and now I'm moving in this particular direction, and again I'm reaching cell 1 3, right? So now by this particular way I have framed the loop for cell 1 3. So now if you see, I have taken a turn only in the only in the cells where the allocation was done. I've taken the turn here, I've taken the turn here, I've taken the turn here, and all this particularly the allocation was previously there, right? Now at some locations I'll have to add, at some locations I'll have to reduce. So no, I have to do allocation in this particular cell, right? So I'll be writing plus here. So that is, I have done the unit allocation here. In this particular cell, I'll be writing minus because I have to reduce the unit allocation in this particular cell. In this cell, I will be writing plus again because I have to do the unit allocation here. And in this cell, I will be writing minus, right? So if you see, I'm going to redraw this again, and no, there is no need of redrawing it again, but I'm doing it just for your understanding. And because you have to repeat it for lot many unallocated cells. So 2 3 11 7 1 0 6 1 5 8 15 9, ठीक है? सो अभी हम लोग क्या कर रहे हैं, मैं जो सेल से वो लिख रहा हूं जहां पे मैंने कुछ ज्यादा किया नहीं है. There is no change, right? Now initially I have done the unit allocation here, right? तो ये प्लस साइन है, तो यहाँ पे मेरा क्या आएगा, I'll be doing the unit allocation here. ये वाला मेरा ये है, यहाँ पे भी मेरा ये पे मैंने माइनस साइन लिखा है. So here what I have to do, I'll have to reduce the unit allocation. So that will be 3 minus 1. So that will be equal to 2. यहाँ पे मैंने क्या लिखा है, यहाँ पे मैंने प्लस लिखा है. So it will be 6 plus 7 is equal to 6 plus 1 is equal to 7. And lastly, I've written minus here, right? So 1 minus 1 is 0, and I won't be writing it again. So now let's check that we have got this particular as a constraint. Now we have got this as a new solution, or what we can say is one of the solution for cell 1 3 if we do some allocation in cell 1 3. So let's check if you have violated the constraint. So here it is 6, here it is 1, and here it is 10. So here it is 7, 5, 3 and 2. They haven't violated, but we have done the allocation in this particular cell C13, right? Now with this particular change, what will happen, and is the cost getting reduced or not, right? So what I have done is, now I have I have added unit cost. So जहाँ पे मैंने addition subtraction किया है ये वाले cell 1 3 के loop में, वो मैं consider करने वाला हूँ. तो कौन सा था, ये वाला cell था जिसमें मैंने plus 11 add किया है, right? ये 11 मैंने add किया है, right? उसके बाद मैंने क्या किया था, यहाँ पे एक माइनस कर दिया, मतलब मैंने क्या किया, एक को माइनस कर दिया, -15. यहाँ पे मैंने एक को ऐड कर दिया, तो मतलब मैंने क्या किया, यहाँ पे +5 ऐड कर दिया. यहाँ पे ऊपर मैंने क्या कर दिया, माइनस कर दिया, तो यहाँ पे मैंने क्या कर दिया, इसको एक माइनस कर दिया. तो हम लोग इसको चेक करने वाले, राइट? सो 11 minus 15, राइट, इट कम्स आउट टू बी -4. minus 4 plus 5 comes out to be 1, and 1 minus 2 comes out to be minus 1. Right? So there are chances that particularly this is called as the cell evaluation. We have done certain cell evaluation here, right? Now, this particular table, what I have drawn, no, this is not to be redrawn again and again. You will be getting to practice. अभी हम लोगों ने क्या किया है, सेल C13 के लिए किया है, बट अभी मैं सेल C14 के लिए थोड़ी ना वापस से ये वाला टेबल बनाऊंगा. एक ही जो हम लोगों का ये वाला टेबल है, उसी के साथ हम लोग क्या करने वाले, खेलने वाले, राइट? और उसी के साथ आगे हम लोग बस अपने विजुअलाइजेशन से क्या करेंगे, आगे आगे बढ़ते जाएंगे. ठीक है, वी डोंट हैव टू नो पर्टिकुलरली, ये प्रैक्टिस से होगा. तो मैं आपको बताता हूं कि हाउ दैट कैन बी डन इन योर विदाउट इरेजिंग द टेबल or without repeating, because we don't have time in examination to repeat all this particular sort of thing. So मैं जो ये WAM solution है, वे WAM solution को ही क्या कर रहा हूँ, यहाँ पे वापस से रिपीट कर रहा हूँ. वैम सॉल्यूशन को ही मैं वापस से रिपीट कर रहा हूँ यहाँ पे, और फिर देखते हैं कि आपको समझ में आता है कि नहीं आता है, क्योंकि बार बार हम लोग उसमें कुछ ये नहीं कर सकते. हम लोग के पास विजुअलाइजेशन के सिवाय और कोई दूसरा चारा भी नहीं है. ठीक है, तो वैम सॉल्यूशन के अनुसार यहाँ पे 1 5, उसके बाद यहाँ पे 1 है, यहाँ पे पास 6 है, यहाँ के 3 है, और यहाँ पे 1 है. तो हम लोग के पास जो नॉन अलोकेटेड सेल से बस मैं उसको लिख रहा हूँ, C13 14, देन वी हैव 21 22, राइट? उसके बाद हम लोग के पास है 2 3 एंड 3 2. तो 1 3 के लिए मैंने पहले से निकाल दिया सेल इवैल्यूएशन, पहले हम लोगों ने -1 किया था. नाउ लेट्स यूज योर इमेजिनेशन फॉर सेल 1 4. ये वाला सेल के लिए अगर हम लोगों को क्या करना है, आपको इमेजिनेशन करना है कि ये इसके लिए लूप कैसे बनेगा. से अभी सेल 1 4 के लिए अगर हम लोग गए तो सेल 1 4, आई एम होपिंग दैट द माउस पॉइंटर इज विजिबल नाउ. ठीक है, तो अगर हम लोग सेल 1 4 से लेके गए तो सेल 1 4 से 1 4 के यहाँ पे हमको एक लूप तैयार करना है. तो हम लोग क्या कर सकते हैं, इधर वी कैन मूव इन टूवर्ड्स सेल 1 1, or we can move towards cell 3 4, right? So let's move towards cell 3 4, right? So 7 cell we started from this cell 1 4 and we have moved towards cell 3 4, right? So at this particular juncture we can take a turn, right? So which turn is allowed here? The left turn is allowed. We are going to move towards cell 3 1. So सेल 3 1 के पास पहुंचे हम लोग. सेल 3 1 के यहाँ पे अलोकेशन है, इसलिए सेल 3 1 के ऊपर वहां पे गए हम लोग. सेल 3 1 हो गया. सो सेल 3 1 से हम लोग ऊपर जा सकते हैं, बिकॉज सेल 1 1 के पास हम लोग के पास अलोकेशन है, राइट? सो सेल 1 1 के यहाँ पे हम लोगों ने अलोकेशन किया, और वापस से हम लोग लूप कंप्लीट करने के लिए सेल 1 4 की तरफ चले गए, राइट? सो व्हाट टर्न्स वी हैव टेकन, वी हैव स्टार्टेड फ्रॉम सेल 1 4, then we have moved towards cell 3 4, then we have moved towards cell 3 1, and then we have moved towards cell 1 1, right? So now I am writing here. So the addition is to be done in cell 1 4. So I will be writing cell 1 4 minus the subtraction is to be done in cell 3 4, to cell 3 4, plus the addition is to be done in cell 3 1, and then the addition and the subtraction is to be done, the subtraction is to be done for cell 1 1. So if you put the values and now find out, so it will be 7 minus 9 plus 5 plus 2 is equal to plus 1. ठीक है, so we'll be doing it one more time for cell 2 1 now. Anyone tell me if my the mouse pointer is visible or not? You can write in in the chat box mouse pointer visible? I've got some messages overlap. There is some overlap that is happening. Should I repeat again? In chat section, you can tell me. Should I repeat again this particular this next page? Visible mouse pointer. Was it overlapping? No need. Okay. Okay, no need of repetition. Okay, but a mouse pointer is visible, and that is good. Okay, we'll be doing few more loop formation, and then I'll be asking you if you have understood this or not. Now we have to do the loop formation for cell 2-1. Right. So in cell 2-1 we have to do, and we are going to take turns only in the allocated cells. Right. So we are going to start with cell 2-1. Right, then we are going to move towards cell 1-4, right, because their allocation is there and we can take the turn. Then we are going to move towards cell, okay, we started with cell 2-1, then we are going to move towards cell 2-4, not 2-1-4, it is cell 2-4. After that we are going to come downwards to cell 3-4, and then we are going to move towards cell 3-1, and in upward fashion we'll be moving and we will be completing the loop. So here for cell 2-1 we are seeking for cell 2-1, so obviously it will be plus sign. For cell 2-4 you will be getting the minus sign, right? So for cell 3-4 you will be again getting a positive sign, and for cell 3-1 you'll be getting the negative sign. So now up till now you would have got that I'm putting alternate positive and negative sign. So that is basic funda, that you have to put the alternate positive and negative sign. Positive sign starting with the positive sign where the allocation is to be done, and then minus plus till you reach the loop. Okay, so here what will be the values that you will be putting? It will be I'll be repeating the cell 2-1, so it will be 1, right? So it will be 1 minus 1 plus 9 minus 5. So the value that you get is plus 4, right? So let's do it for cell 2-2. Right, so this is the cell 2-2, and that we are going to now use. Now for cell 2-2, I want you to use your imagination here. See, for cell 2-2, what is going to happen? You'll have to use certain, your imagination should be good, or at least particularly you should try out it properly. See, in cell 2-2, what is happening? We are going to start with cell 2-2, right? Then we are going to move towards your cell 2-4. Then we are going to move downwards towards cell. Which cell is that? Cell 3-4. Then we are going to move in this direction towards cell 3-1, right? Next we are going to move towards cell 1-1. Then we are going to move towards the cell 2-3, and in that way we are going to reach cell 2-2. So for cell 2-2, it was not a conventional way. We started from here, we went here, we went here, we went here, we went here, and likewise we have reached to our cell 2-2. So we can put the alternate positive and negative sign. For cell 2-2 we had positive, then here minus, positive, minus, positive, minus. So if you do the calculation, you'll have to write, I'm going to write it here. So for this it will be 0, minus 1, plus 9 minus 5 plus 2 minus 3 is equal to, it is equal to, okay, it is not C23, it is, okay, did I made a mistake here? See, we have started, no, I'll be making you the loop only here, so that, basically when start telling the cells, it sometimes is a no confusion. So here we started like this, we moved here, then we moved here, then we moved here, and then we moved here, right? So I basically would have no C11, and then it is C12, not C23. So it is C12. Yeah. Yeah, see, you should ask something because particularly, so here the loop will get complete, right? So this is the loop formation that has happened for this cell 2 2. That was not conventional. So basically, normally, few of these cells you will be finding that it is not conventional. Yeah. Okay. Okay. Now let's know understand the this cell no loop formation for cell 2 3. In cell 2 3, how we can move is, now if I have to go for cell 2 3, no, which is this cell 2 3. So it is very simple. If you see that I have to do the allocation in cell 2 3, so this particular loop can be formed in this particular way. So I am representing it with the dotted points. Very simple. So what we can do is we can start with cell 2 3 itself, then we can move towards cell 2 4, then we'll be moving towards cell 3 4, and then we'll be moving towards cell 3 3, and likewise we are going to reach the cell 3 the cell 2 3, right? So if you put the values here, right, so you'll be getting the values as so C23 is it is 6 minus 1 plus 9 plus 50 6 minus 1 6 minus 1 plus 9 minus 15, you'll be getting the answer as minus 1. The answer will come as minus 1. Lastly, we have cell 3 2. So lastly, this is the cell 3 2. And to do the allocation in this cell, what we can do is we can move from cell 3 2 towards cell 3 1. Then we can take a turn at cell 1 1, and then cell 1 2, and likewise we can reach downwards. So this is the cell in which we have to do the allocation. So we'll be moving in this direction, then after that we are going to move in this direction, we are going to move in this direction, and then we are going to reach again here. So this is the loop formation that we can do. So again here is plus minus, and that will be 8 minus 5 plus 2 minus 3 will be equal to 2. So this is how the cell allocation is to be done. No, cell evaluation, sorry. The cell evaluation is to be done. Now, what is the purpose of doing this cell evaluation? Right? So, the very important purpose, if you get all positive signs, you have got optimal solution. So if you get all the positive signs for the cell evaluation, so what we did now was the cell evaluation, right? And for all the cell evaluations, if you have got the positive sign, you have got the optimal solution. If you have got negative sign, no you no optimal solution reached. And iterate further. So you'll have to further iterate to get a optimal solution, right? But how, you'll have to do some allocation now. Okay. Now where you will be doing allocate in cell with highest number with negative sign. So we are going to do the allocation in a cell with the highest number with negative sign. Right. So the highest number, now unfortunately what we have here is we have got a tie. Right. So when we have got a tie, so what is going to happen here? So no. We have received a tie here. So what is to be done here? So if there is tie, allocate in the cell with maximum wherever max allocation is possible. Okay. So no, I'll be repeating the table here. And we'll be identifying in which cell we can do the allocation. So it is 2, 3, 11, 7, 1, 0, 6, 1, 5, 8, 15, 9. It is 1, 5, 1. So this is what I'm writing is the VAM solution only. The solution that we have obtained from VAM only. So now what we can do here is, we'll have to do some, we'll have to, they are telling that, if there, we'll have to identify those cells in which the negative sign is there, right? And for that particular negative sign, now in those cells which have received the negative sign, in those cells we can do the allocation. Now amongst that particular cell also, we'll have to select a cell which is having the highest number with a negative sign. Right. So if you would have got some cell evaluation as -4, so we would have taken that particular cell for the allocation because 4 is greater than 1 with a negative sign. Right. So particularly that cell is to be identified for the allocation. But now unfortunately what has happened, there is a tie in our case where we have got, cell 1, which are the cell? We have got cell 1, we have got cell 1 3 and cell 2 3 in which the allocation, the cell evaluation that we have got is -1 only. So we have got it as -1 in cell 1 3 and cell 2 3, right? So in which cell 1 3 and 2 3, in these two cells. So now we have to check. Now there is a tie, so we'll be checking where we can do the maximum allocation, right? So 7 5 3 1. So 3 2, sorry. Right. So we'll have to check whether we can do the maximum allocation here or the maximum allocation here, right? So if we try to put, let's check that for cell 3 1, our loop formation will take place. How our loop formation will take in this particular format. And the maximum cell, तो मतलब हम लोग कितना रिड्यूस कर सकते हैं, मतलब ये वाले को हमको क्या करना पड़ेगा, ये वाले को हमको एलिमिनेट करके यहाँ पे डालना पड़ेगा, राइट? सो दैट इज द सेल एलोकेशन. तो हम लोग कितना एलोकेट कर सकते हैं मैक्सिमम इस जगह पे 1 एलोकेट कर सकते हैं, राइट? सिमिलरली अगर हम लोग ये वाले इसमें लिए चेक करें, ये वाला जो सेल है इसका जो लूप फॉर्म होता है वो ऐसा लूप फॉर्म होता है. बराबर। और यहाँ पे भी अगर हमको एलोकेशन करना है तो हमको क्या करना पड़ेगा, ये जो 1 है यहाँ पे प्रीवियसली 1 एलोकेशन था, तो ये वाला जो 1 है उसको रिड्यूस करके उसको निकाल के यहाँ पे डालना पड़ेगा। तो अभी क्या क्या हुआ, यहाँ पे भी मैक्सिमम एलोकेशन के इसमें भी हम लोगों का टाई हो गया। तो व्हाट दे वर वेरेवर मैक्सिमम एलोकेशन इज पॉसिबल, उधर ये बोल रहे थे कि उधर ट्राई करो, पर अभी उतना हो नहीं रहा है। तो अभी हमको क्या करना पड़ेगा, मैक्सिमम एलोकेशन के केस में भी हम लोगों का टाई हो गया, तो आर्बिट्री हम लोग क्या करने वाले, वी आर गोइंग टू सेलेक्ट एनी सेल आर्बिट्ररीली and in that cell we are going to do the allocation. So now let's start with, when we are saying that it is to be done arbitrarily, so let's start with the allocation to be done for cell 1 3 और हम लोग आगे बढ़ते, right? Just a second. Now what we are going to iterate towards, the optimal solution. Now we are going to actually use our step number 3 here. Right, so what we are going to do is we are going to arbitrary selection of cell 1 3 for allocation, right? So we are going to, मैं वैम का सॉल्यूशन यहाँ पे आप लोगों को रेफरेंस के लिए ये करता हूं, और वो वैम सॉल्यूशन से फिर आगे हमको और एक सॉल्यूशन अभी डिराइव करना है। वैम का सॉल्यूशन ये था 2 3 11 7 1 0 6 1 5 8 15 and 9. Right, so this was the VAM solution with us. Now we are going, doing the allocation in cell 1 3. So that is cell 1 3. We have selected it arbitrarily, and then we are going to do the allocation here. Right. So allocation मतलब हम लोग क्या करने वाले, the same repetition of this step. So therefore the new solution obtained is yeah. So the new solution that we are going to obtain is, now we यहाँ पे ये करना है, तो मतलब हम लोगों को इसका लूप पकड़ना होगा। तो ये वाला लूप है, तो लूप है मतलब यहाँ पे आएगा प्लस, यहाँ पे आएगा माइनस, यहाँ पे आएगा प्लस, और यहाँ पे आएगा माइनस। तो सिमिलर वे में हम लोग ये करने वाले, तो यहाँ पे आएगा प्लस, +1 हो गया, यहाँ पे -1 होगा, मतलब 3 - 1 is 2, यहाँ पे 6 + 1 है तो ये 7 हो गया, यहाँ पे 1 - 1 है तो ये 0 हो गया। बाकी सब आपके जो अलोकेशन से वो सेम ही रहेंगे। तो आपके कंस्ट्रेंट्स भी आप लोग देखो, तो 5 + 1 is 6, here is 1, 7 + 2 + 1 is 10, here it is 7 5 3 and 2, right? So this is the new solution that we have obtained. Now we have obtained this new solution. Again the case is that we'll have to check its optimality. So again we have to repeat all these steps that we have seen. So check for optimality. Immediately when we write check for optimality, we'll be checking the number of allocations is equal to 6, and m plus n minus 1 is equal to 6. Hence we are going to proceed in the further direction. In further direction matlab kya? Now for all unallocated cells, we are going to find out the cell evaluation value, right? So cell evaluation values for all unallocated cells. So I'm going to redraw the new solution that we have got here. This was the new solution that we have obtained after doing the allocation in cell 1, 3. So the unallocated cells here are which? Here the unallocated cells are 1, 1. Then it is 1, 4, 1, okay, 2, 1, 2, 2, 2, 3, and 3, 2. So you are going to check with the loop formation here again. So I want you to pay the attention because I'm going to do the process, and you will be seeing this and understand. I will be sending you the PDF copy, and you will be trying to understand this process again via the PDF copy, right? So cell evaluation values for all the unallocated cells that I'm going to tell. So for cell 1, 1, for going for cell 1, 1, we'll have to move. We'll have to start from cell 1, 1. Then we'll be moving towards the cell 1, 3. We'll be moving towards the cell 3, 3. Then we'll be moving towards the cell 3, 1, and then we are going to move. Then we are again going to move towards cell 1, 1. So here it is positive, minus, plus, and minus. If you substitute the values for this iteration, so what will be the values? Anyone? What will be the value? So it will be 2 minus, it will be this value. So the loop is like this. From here, it is moving towards here. So it is moving towards here, it is moving towards here, and then it is moving here. So it will be 2 minus 11 plus 15 plus 5, right? So the value comes out to be 2 minus 11 will be minus 9 plus 15 minus 5 is equal to plus 1, right? So this is how we are getting. So for now, for cell 1, 4. So for cell 1, 4, I'm writing cell 1, 4. So it will be C1, 4. So I'll be moving in the downward direction towards cell 3, 4. I'll be moving in the leftward direction towards cell 3, 3. And then I will be moving towards in upward direction for cell 1, 3. So minus, plus, minus. So here the loop formation is like this. So we have to do the loop formation for this. So here, from here we'll be moving towards, from 7 we'll be moving towards 9. From 9 we'll be moving towards 15. From 15 we'll be moving towards 11. So the the equation becomes 7 minus 9 plus 15 plus 11. Sorry, it will be 7 minus 9 plus 15 minus 11 will be equal to plus 2, right? Similarly, we are going to check the optimality for cell evaluation for cell 2, 1. So for cell 2, 1, what we will be doing? So for cell 2, 1, I will be writing the loop. So the cell, it will be C2, 1 minus C2, 4 plus C3, 4 minus C3, 1, right? So we started from this 1, we'll be moving towards this 1, we'll be moving towards this 9, and then we'll be moving towards this 5. So it will be 1 minus 1 plus 9 minus 5 will be equal to plus 4. Right? So for cell 2, how we are going to do it? Again, some complex thing for cell 2. So C22 minus C24 plus C34 minus C31 plus C11 minus C12 is equal to. So yeah, so we have started from 0. We are moving towards 1. From 1 we are going to move towards 9. From 9 we are going to move towards 5. From 5 we are going to move towards 2. And from 2 we are moved towards 3. And by that we are going to reach to 0. So here we have to do, what will be the equation? It will be 0 minus 1 plus 9 minus 5 plus, okay, is there any problem? Yeah, I think that we cannot move in this particular fashion for C22 because I've taken a wrong turn here. You do not have any allocation, so I can't move in this direction and I can't get into this. So we'll have to take some alternate path for this, which was very, very simple. Yeah, for C22, I'm writing it here now. See, for C22, what I'm going to do now is I'll be taking the path of C22 minus C2. No, it will be, yeah. Just a second, let me rethink as well. So it will be from 0, we can start in this direction. I'll have to move in this direction. Then this. Okay, it is simple. 0 to here, then here, then here, then here, then here. Okay, so it will be C22, from which I will be moving towards C24. Yeah, then I will be moving towards C34. I'll be moving towards C33. Then I will be moving towards C13. And then I'll be reaching C12, and via that I'll be moving towards downward path, right? So I will be starting from 0, then I will be reaching 1. From 1 I'll be reaching 9. From 9 I'll be reaching 15. From 15 I'll be reaching 11. From 11 I'll be reaching 3, and from 3 I'll be again reaching 0. So this loop is moving in this direction from 0 to 1, 1 to 9, 9 to 15, 15 to 11, and 11 to 3, right? So I'm not making the dotted lines because then again it will be creating confusion for further thing. So the equation will be 0 minus 1 plus 9 plus 0 minus 1 plus 9 minus 15 plus 11 minus 3. So if you do that, you'll be getting the value as plus 1, right? So for C23, let's do it for C23. Again, very easy. C23 minus C24 plus C34 minus C33. So it is very easy to obtain the path via this. So this is the loop that you get a form. So perfect square. So 6, then 1, then 9, then 12. So 6 minus 1 plus 9 minus 15 is the loop that we get. And if you put the values, you'll be getting the answer as minus 1. Next, we have to move ahead and check it for our last cell, that is C32. And when we do it for C32, we can move in this direction. C32 minus C12 plus C13 minus C33 is equal to. So the loop formation is like this: from 8 towards 3, from 3 towards 11, from 11 towards 15. So the equation will be 8 minus 3 plus 11 minus 15 is equal to plus 1. Right? So this is how the cell evaluation are taking place. Now, if all the values would have been positive, we would have got the optimal solution. But here you can see there is a negative value that we are obtaining, that is minus 1. And again, the solution is not an optimal solution. There is only one minus value that we have got, and that particularly suggests that we have to do the allocation in C23. So we are going to finish this numerical. With this step, let's move towards the optimal solution, so that in more 5 to 10 minutes I'll be finishing this. Right? So optimal solution not reached, hence iterate further by allocating value in, which is that cell 2, 3. So now we again are not going to go back to the VAM solution. This is the solution what we have got. Now we are going to do the alteration in this solution only, right? So I'm copy pasting this solution here on the next page. So the solution that we have got from our first iteration, that is only to be used for the second iteration, right? Simple as that. So our previous solution is 5, 1. Then we have one allocation here. We have 7, 2, and 1. This allocation here. So this was the previous solution iteration that we tried, and for this solution we found that it is not optimal. So we'll be moving ahead. We'll be do allocation. So do allocation in cell. Which cell? The cell is 2, 3. So the 2, 3 cell is this particular cell. We have to do the allocation is cell 2, 3. So again, we are going to do the allocation. So for doing the allocation, the loop formation for this cell 2, 3 will be like this. So here it will be positive, here it will be negative, here it will be positive, and here it will be negative, right? So what will be, here it will be how much? Okay, I'll be redrawing it, and then we'll be getting the solution for checking the optimality. Right, so we did allocation here. So 5 and 1, this won't be changing. What will be the change will be that here you'll be getting 6 plus here you'll be getting 1 as an allocation. So 1 minus 1 will be 0. 1 plus 1 will be here 2, and here 2 minus 1 is 1, and the constraints will get satisfied. So here 5 plus 1 is 6. Here we have 1. Here we have 7 plus 1 is 8, 2. Here again we have 7, 5, 3, and 2. So the new solution, what has happened here, previously here in this particular cell there was no allocation, right? So we did an allocation, right? So here we got an allocation of 1. Why 1? Because in that particular row only one digit, only 1 million liter was, it was there. So here it is 1. That 1 got subtracted here, so it is 0 here. So there is no allocation in this particular cell as of now. Nextly, we have got 1 plus 1 is 2, and 2 minus 1 is 1 here. So we are going to check the optimality. and then we'll be deciding whether this is an optimal solution or not. Check for optimality. The number of allocations is 6. M plus n minus 1 is also 6. Proceed. So the unallocated cells, what we have is C. Oh, sorry. We have is 1, comma 1. We have 1, comma 4. We have 2, comma 1, 2, comma 2, 2, comma 4. And lastly, we have 3, comma 2. So we have to again check with the loop formation here. So I'm going to form the loop here for C11, the loop formation that I can do now that the allocation has changed. You'll have to be more alert for doing the allocation. So my loop formation will go here like this: C11 minus C13 plus C33 minus C31, and then it will be moving upward. So that will be my loop formation I've done in this manner. From 2 I have moved towards 11. From 11 I have moved towards 15. From 15 I moved towards 5, and from 5 I have moved towards 2. So that will be, the equation is 2 minus 11 plus 15 plus 5. Yeah, it is 2 minus 11 plus 15 minus 5. So if you put the value, you'll be getting the answer as plus 1. Right? Let's move ahead with cell 14. So for cell 14, the loop formation that I'm targeting is C14 minus C34, right? So plus C33 plus C13, right? So the loop formation that I have done is from 7 to 9, 9 to 15, and 15 to 11. So the equation is 7 minus 9 plus 15 minus 11 is equal to plus 2, right? For C21, the loop formation that I need to do is C21 minus, I'll be moving towards C. It is C23 plus, it will be C33 minus C31, right? So the loop formation is like this: C21, 1 from 1 to 6, 6 to 15, 15 to 5. So the equation will be 1 minus 6 plus 15 minus 5 is equal to plus 5. Similarly, we can do it for C22. So for C22, let me check it again, because C22 is, now here it is, C22 is very, very simple. So C22 minus C12 plus plus C13 minus C13 minus 23. Okay, so it is 0 minus 3 plus 11 minus 6, and that value comes out to be plus 2. For 24, I can go with C24 minus C34 plus C33 minus C23, right? So this is simple. It is 1 minus 9 plus 15 plus 6, and it happens, it is 1 minus 9 plus 15 minus 6 is equal to plus 1. And lastly, we have cell 32. So for cell 32, again the loop formation is easy: C32 minus C12 plus C13 minus C33 is equal to, so the loop formation is 8, then 3, then 11, then 15. So the values are 8 minus 3 plus 11 minus 15, which comes out to be plus 1. Okay, so here all values are positive. All values are positive. Hence, what we have received is, hence optimal solution is reached. Hence, the optimal solution so according to the optimal solution, what we have got, supply 5 ml, that is 5 million liter to distribution center 2 and 1 million liter to distribution center 3 from plant 1. Right? So if you see the table, you will be understanding it, right? We have also got that supply 1 million liter to distribution center 3 from plant number 2. Again, we have got supply 7 million liter to distribution center 1, 1 million liter to distribution center 3, and 4 million liter to distribution center 4 from plant 3. This is how the answer that we have got